Okay, so this is Rebecca and this is Juliana. They're both playing around on their computer simulations. Juliana likes the advanced version because she can make them bounce in the box. Here.
Box bouncer.
Yeah. But Rebecca, tell me, what are you doing here on your simulation?
I'm making the balls bounce.
Making the balls bounce? How?
Well, the number one ball is...
Are you making them face each other and hit each other?
Yeah, well, the red ball is facing this way, and the green ball is facing that way. And they're coming at each other, but the red ball is going much faster than the blue ball is. And the red ball will hit the blue ball. No, it's not blue, it's green. I'm not colorblind. And they'll hit each other, like in billiards, and go off the screen.
Okay, so what's this data you're taking down?
So I'm taking the mass of each ball and the velocity, and then the momentum.
Looks like you haven't figured out the kinetic energy yet. Do you know how to do that?
So the kinetic energy is 1/2 the mass times the velocity squared.
Okay, so then you just, which things are you going to plug into that equation then from up here?
So I'm going to take the mass and the velocity, and I'm going to put it down here, and I'm going to square it, and I'm going to divide that by 2.
Mm-hmm.
And then it'll give me the kinetic energy.
There you go. So it looks like you've got the inelastic ones too. What are you going to do with that?
So what I'm going to do is I'm going to take it, there's a little toggle right here, and it'll give me elastic, and then drag it all the way down here, and it'll give me inelastic.
Good deal. And you haven't done inelastic equations yet, but do you figure that the inelastic equations will bounce the same as the elastic ones, or what do you think?
No, because elastic is it's a term that even children use, but in reality it's a scientific term, like rubber bands and stuff, and we think of it as stretching outwards, but it also stretches back inwards, and it's bouncy. It bounces off of it. So when the balls hit each other, it bounces off, but really it's kind of, I think that they'll stick to each other. It just kind of...
Yeah, so the inelastic ones, they just kind of push and...
Yeah,
right?
kind of like if you rear-end a car, and instead of the car, because the car is so huge, it just kind of doesn't bounce off, it just kind of pushes.
Now tell me, Rebecca, can energy be created or destroyed?
No, it can only transfer forms.
There you go. So with momentum, here it looks like you're recording that. Why do I need to know a momentum of something?
Well, there's lots of reasons why we need to know the momentum of something. And engineers couldn't make anything without the momentum of something. Like an off-ramp on a freeway.
There you go.
We can't scale it to the perfect curve unless we knew the momentum of a car coming off the freeway.
Well, there you go. And that's why they set speed limits certain ways too. Yes, for sure. Okay, cool. So what's been your favorite thing to play with so far?
I like making the balls bounce and then slowing it really down.
What did you notice about making the masses bigger or smaller?
The bigger they are, the faster they go off the screen.
Yeah. So really, if I had a smaller object going really fast and a bigger object going slower, do you think it would make a difference?
Yeah.
Let's see what would happen.
Big object going fast and small object going slow.
Or actually opposite, make the big object go slow and the small object go fast, see if it affects it.
Let's see. There we go.
And play. Did it even do anything?
Okay, let me restart it, and Here we go.
Ready?
Okay. I'm gonna switch it to elastic.
Okay.
Ready? Play.
Did it do anything?
It did. You could see the ball moving. Like, here, I'll put this up against, you can see where it's lined up right here.
Okay.
And you can see where it's moving.
So momentum is the same on both sides, right? But yes, like sometimes the numbers will rearrange, but they'll always be the same amount of momentum distributed on both sides.
And see, it's reached the top of the cap now.
That's fun. Juliana, what's been your favorite part of this little simulation?
Just playing with it and watching the balls bounce.
Cool.
And seeing if it will hit the corner in the box.
Mm-hmm.
Alright, do you need me?